scared about half of you away. I'm hoping I can hang on to the rest. Fantastic. Alrighty, so my name is Kelsey Moody, and thank you very much, Jess, for inviting Aaron and I to come down and talk to you guys a little bit about the history of our company. So this is going to be a really fun two-part discussion. First part, we're going to talk about all kinds of boring business things, and then we're going to get into some hard translational science. This is our little graphic of the Ichor empire. Ichor Therapeutics itself is a contract research organization that does work for hire in the life sciences. We make a bunch of money, and we use that money to develop drugs for different diseases, which we put in all of these different companies around the circle. Enough of that. Title of the talk, Living Room Translational Initiatives. It is possible, apparently, to start a company in your living room. So I'll be taking you a little bit through our adventure in this process and discuss a little bit how we've gone from a very early stage startup in Syracuse, New York, to a major player in the field of macular degeneration. Again, really thankful that Jess gave me the invite to come out. I really love talking at these sorts of events because, you know, when we look around society these days, there's always this focus on what people have, right? We define ourselves by how big our house is, how much money we make, what kind of job we have. And there's less of a focus on what we build and how we build it. And what I love about coming to these sorts of conferences, I think that scientists are kind of innately focused on the processes behind our discoveries and rolling those discoveries out into things that can make the world better for everybody. And kind of the reason I do this two-part business and science talk is the science is very important, but we also have to appreciate the discoveries that we make in the laboratory cannot be useful for people unless they're turned into products, right? You're studying pathways of disease, they need to be translated into drugs. You're developing research tools, they need to turn into some sort of kit that can be purchased off the shelf for scientific use. Financial disclosures, everything I'm going to talk about is for profit because we're a company. And I know that everyone says that they have the very best team. Everyone else is wrong, I do. The team at Ichor is phenomenal. We've got a bunch of PhDs, masters, and bachelor level people. They do a great job in producing all of the data that we're going to be talking about today. Also financial support, we've received venture capital, grants, the works, and a lot of private investments from high net worth individuals, which we greatly appreciate and allow all of our research to be possible. And I'd like to start the story of Ichor back in 2010, and the reason for that is I had just wrapped up my undergraduate degree in biochemistry at SUNY Plattsburgh in a not so unfamiliar position as all of you in this audience. And I was very fortunate to get recruited by this guy, John Schlorndorn, who's a graduate student at Arizona State University and had moved to Silicon Valley in California to start a biotechnology company that was focused on oncology. If you go to Google and type in Silicon Valley Garage Lab, these are the pictures that will pop up, and that was my stomping ground straight out of undergrad. John got picked up on the radar of this guy, Peter Thiel, who you might know. He founded PayPal. That was his first $1 billion when that exited to eBay. If any of you have seen The Social Network, he was the guy that gave the first $500,000 check to Mark Zuckerberg and allowed Facebook to happen. He's one of the top investors in Silicon Valley. And he found John and gave him $1.5 million to found ImmunePath, an oncology company where I was able to serve as chief technology officer right out of undergrad. Now, chief technology officer means that I automate things. I take robots and I have them automate various laboratory processes. Of course, I was straight out of undergrad, so I had the entry-level position of doing lab automation, but also making coffee. So I automated that because that's what automation people do. But I also automated a lot of other really useful techniques that might be familiar to you guys in your research. And enzyme-linked immunosorbent assay, mammalian cell culture, qPCR, and of course mRNA isolation, et cetera, et cetera. And this was really useful for me because I got to experience a wide range of different technical methodologies and automate them on a high throughput screening platform, which has been really helpful as Ichor itself has advanced now. We've taken a lot of this knowledge and deployed it at our own company. Now, the problem with doing early stage startup work is more often than not, the companies fail. And unfortunately, that's what happened with ImmunePath. Despite having a very strong, very workable cell-based therapy, we weren't able to close the amount of funding that we needed to move on to the next steps. And so I found myself at Upstate Medical University as a medical student. So when I went to med school, I was very keen on building a pharmaceutical company. I'm really driven and passionate about developing drugs for diseases that no one else can do anything about because that's just, I think that's the area where I can make the biggest difference. And it was kind of funny, when I was interviewing at Upstate, they asked me why I want to be a physician, and I said I don't. I want to understand how hospitals work so I can make drugs that can be deployed in a clinical setting, and they still let me in. I have no idea why, but I was appreciative of that. While I was a student, I still wanted to get involved in a lot of research, and unfortunately, the life of a medical student isn't really compatible with being able to do research. So I started doing research on the side and actually applied, independent of any faculty support, for a research grant, which I actually won for $450,000. To my knowledge, that's the largest grant ever won independently by a student at the university. And for a number of different reasons, I decided not to do the research at the university, but I instead decided that I wanted to set up my own for-profit company off-site. And the main driver for this is when I was in Silicon Valley and when ImmunePath died, our company in Silicon Valley, we had all this great infrastructure, we had a really great team, but when we had that funding lapse, we had to liquidate everything, and it just takes a really long time to put that infrastructure back in place. So when I decided to pursue this project, my goal from day one was really this idea of having a physical lab that I owned completely, that had a small enough amount of overhead that I was never without a lab again. And if you're a broke medical student that's just starting off a startup company in central New York, what better place than moving into your apartment? So that's what we did. A couple of you in the audience are from the Syracuse area. This is in Tipperary Hill, strategically located between Roslyn Gifford Zoo and Coleman's Irish Pub. Picture on the right, moving laboratory equipment in. These are some friends of mine from medical school. You'll see I was in slightly better shape back then, moving heavy equipment around, and we set up a fully functioning cell biology laboratory in our apartment. These are a few pictures from there, and when you're setting up a lab, we have these really cool kind of nice shiny instruments that you can buy, but there's so many companies that start up and go right out of business. There's a huge secondary market now for the capital infrastructure. So it used to be, if you wanted to do biomedical research, you had to partner with universities, either being an academic or a company that partners, or you have to work with a big pharmaceutical company in order to have access to all the toys. That is not the case anymore, and you can equip a full laboratory for a couple $100,000, which is in the range of what you can raise for seed funding for cool projects. So a few things we like to point to just to be cheeky. We need to autoclave reagents and consumables. Grandma's pressure cookers and canning jars actually do a great job. And you guys are laughing, don't hold it against me. So early on, we identified that quality control is a thing. So what we did, we wanted to make sure we could get away with grandma's cooking jars and pressure cookers. So those really nice kits, I'm not talking about the tape that changes colors, but the nice kits that you use to do quality control on your room-size autoclaves. I found out exactly what they used at Upstate Medical, and that's what I used to validate my pressure cookers in the living room. And this is a recurring focus of the company. We've been focused on quality assurance and reproducibility since day one, and that's really, really integrated into the culture of our company. So even at the level of the living room, we were doing quality control testing on all of our instruments and really making sure, especially when you're dealing with used equipment, you need to make sure it's operating at the specifications necessary to produce accurate results. Now, one of the challenges that we ran into is my background is in hematology and stem cell differentiation. So at ImmunePath, I did automation, but I also took human embryonic stem cells, differentiated them into various hematological products, and we did xenograft modeling. So this is where you have immunocompromised mice. You can administer cells to them, and they engraft just like in a person, and you can track their function and these sorts of things. But to do that at the level of the living room, I needed a vivarium or a mouse facility. So I built that too. So this is one of our bedrooms in the 3-bedroom apartment. That's my girlfriend. I don't know why she's still dating me, but she is, God bless her. And we actually constructed in a normal apartment bedroom a skid vivarium, so specific pathogen free. Now, you guys aren't laughing quite as much as you were about the autoclave, but even at the level of the vivarium in the living room, we were following all of the quality assurance necessary to make sure that these mice were reliable and specific pathogen free. And I know that because my girlfriend was completing her doctorate in veterinary medicine at Cornell, top veterinary school on the planet at this time, and was hanging around in their vivarium and all the qPCR testing for serology, sentinel systems, water testing, air quality testing. We were doing all of that at the level of the living room from day one. And it's kind of an additional side note that we physically built out the facility. So as we built out follow-on facilities moving forward, we started to understand where the major components, what the major components are that lead to a successful facility, not just in terms of HVAC and airflow and these sort of things, but also operations and workflow and all of that. So these are some pictures of our cute little mice. Got some black 6s and some skids. And the way that we designed this is we actually framed out the with just regular studs, 2x4s. These are HEPA filtered air purifiers from Walmart. Piped into the room through galvanized heating duct. We use this insulation material in and out, which is resistant to UV, bleach, and alcohol, so we can keep the whole thing clean. And very conveniently, this room used to be a laundry room, so that spot in your laundry room where the dryer exhausts, that was our high pressure blow off, so we were able to keep this entire thing pressurized, gown in, gown out with the scrubs and the masks and the gowns and the whole shebang. We were able to keep about 100, 150 mice specific pathogen free here for a number of experiments while we were still operating at the level of the living room. Now, we're going to pick up on this story for Ichor 2.0 and 3.0 in just a minute. But before we go there, this is a science conference after all, so I probably should talk a little bit about science. So one of the early projects that we jumped into in the living room, actually, was looking at this disease, age-related macular degeneration. So age-related macular degeneration is a leading cause of vision loss in people over the age of 50, with something on the order of 200 million patients affected globally, and a direct healthcare expenditure on the order of 250 billion. And when we think about the disease, it's really not surprising that it has such detrimental effects, because this is a disease of the central vision. So we appreciate that we have central vision that gives us the high acuity vision when we're looking at things, and then we have kind of peripheral vision that is less focused. And in age-related macular degeneration, these folks have a progressive deterioration of the central vision, and it really impacts quality of life and their ability to interact with the world. Now, if we look a little bit into the anatomy and microanatomy, so vision comes from the retina. This is a cross-section of the eye, and the part of the retina that drives central vision is actually this little indented area here on the back called the macula. And if we zoom in on the macula, we can appreciate that there's a very complex microanatomical architecture that really drives function. So there's various neural layers shown here in blue and red, but the area that we're going to focus on are the photoreceptors in yellow and purple, and the retinal pigmented epithelial cells, or RPE, in tan on the posterior side. And the relationship between these photoreceptors and the RPE is really, really important for our ability to see. As a general rule in biology, if something gets blasted by light, that tends to be highly damaging and necessitates a certain level of cellular turnover. So the photoreceptors are constantly growing from their cell body towards the RPE, and the RPE are constantly gobbling them up and breaking them down and assisting with metabolic function. What's recently been appreciated is that retinal pigmented epithelial cells behave an awful lot like macrophages and other phagocytic cells. And this is going to be very relevant for how we've pursued a therapeutic strategy for treating the disease. So I'll just explain a little bit about how macular degeneration itself occurs and progresses. And this really boils down to dysfunction of the lysosomes in RPE cells. So for those of you that remember your cell biology, cells have a bunch of lysosomes within them, and the lysosomes are where things are sent that need to be degraded. And within the lysosomes, we have all manner of different enzymes that can break down all of the stuff that makes us us, and this is essential for cell and other product turnover. If we are missing, usually through some sort of genetic mutation, one of these essential lysosomal enzymes, we can get a lysosomal storage disease. The pathology of the disease, the junk that accumulates, the tissues that are affected, is entirely driven by what enzyme is not functioning properly and what type of junk is accumulating as a result of that. And what's really interesting is that age-related macular degeneration seems to be very similar to a lysosomal storage disease. As those photoreceptors are being turned over, vitamin A derivatives that cannot be broken down by the body accumulate in the RPE cells and eventually cause them to die. And because of this, we really frame age-related macular degeneration as a lysosomal storage disease, but unlike a lysosomal storage disease, which occurs because of a genetic mutation, so we're missing an enzyme we should